So, what a week it's been, huh? How many people still don't have power, just out of curiosity? I don't have power, just two of us? Okay. So it could have been a lot worse. So who has a good story they want to start off with? Who has a good hurricane story? Anyone have anything interesting or exciting? What's that? You almost died?
No, I just decided to drive back during the hurricane, so I missed traffic. It was fine.
How many people went out of state? Just out of curiosity. See. Oh my, almost everyone. Okay. So why don't we get started? What questions do we have starting off with? Questions anyone has? Everybody's good?
For the homework? Questions about what?
About anything. Homework. I tell you what, if we have some time, I am going to write a solution key to the homework, and it is really important. Context is super important because later on when you go to do the hypothesis test, if you don't know context, you can't do the hypothesis test well. One of the rate limiting steps in the hypothesis test, it's one of the most underappreciated, is the fact that you have to be able to answer those basic questions. Being able to answer those questions really clues you in to the hypothesis test and makes life 100 times easier, because there'll be a lot of stuff going on with the hypothesis tests besides the context, and doing both of those at the same time is kind of hard. So hopefully that'll help. So go ahead and open up the notes, and we'll get into StatCrunch in Canvas. We're going to have to download a few data sets in Canvas and open up StatCrunch. Okay, so let's just go get started. So first of all, we want to finish up section 2.1. There's actually a lot going on in 2.1. We're talking about descriptive statistics. Again, I'm going to go back to this big picture. If I can get my thing to work here. That's not working. Okay, so first of all, this is an important slide. This is telling us what we're doing in statistics here. So we're collect data, summarize it, we're going to use probability theory, and then we're going to draw conclusions from that. And so where we're at right now is we finished up collecting the data, okay, and we've talked about all these steps. The goal, we want to get a sample that's like our population, that's representative. We talked about the different collection methods. We want to find at the end of the day the method that's going to give us the sample that best looks like the population. One of the things that you may think, and it's easy to think this, is that it's kind of subjective. For example, when you do cluster and stratified, they seem very similar. And sometimes it's not always obvious which one's correct. For example, with that one we were talking about the fitness levels versus different schools in the college. You could argue that both ways. But here's the thing you want to understand, because you're going to be working with real data sets for the final, for the midterm and stuff like this. A lot of times you do make a guess. But the point is, first of all, we check the assumptions. Okay, so if I was to make an assumption on stratified sampling, I would make sure that everyone in that group, that strata, did kind of look the same. I would check my assumptions. The second is that when you get the right results, everything kind of falls together. Okay, so it isn't really arbitrary, even though I know it seems like it initially. So context, 3 questions you always have to answer: what, how, what, who. That should be who. Sorry. Who and why. Those are the 3 basic questions. I want to know, what is the data collected on? Who was the data taken from, and why? If you can't answer those 3 questions, you have to be really suspect. And again, it's going to let us decide if that data is reliable. Okay, if it's actually valid to work with. We talked about the different data types. The reason why that's important is it segues into what we're going to do now. Okay, so the different data types are going to be summarized different ways. And that's the reason why we care about data types. We treat them statistically very, very different. Categorical versus quantitative, very, very different. Okay. For some reason, it's giving me troubles today. Okay. So, what we do in this second step are three things. This is called exploratory data analysis, or sometimes people call it descriptive statistics. Okay. And so, I want to just kind of make the point that the type of variables you have determines how you're going to summarize things. So the first thing we always do is we look at the data. And the idea is that we're going to want to remove invalid data types. That's going to be the same both for categorical and quantitative. That's the first step we're always going to do. Secondly, we want to plot the data. And this is where they're going to differ. So this is the first place where we see the difference between those two. Totally different plots. It's very easy to think that some of these plots, if you're familiar with statistics, you think the bar graph and the histogram are the same, but they're not. They're looking at very different things. And then finally, we're going to summarize the plot with a few pieces of information. In other words, I want to take that whole plot and I want to be able to just give a few pieces of information that's going to capture the main features without having to describe all the details. Categorical is very simple. There's only one thing we can ever report, which is the mode. You can report the number of categories and the sample size, but at the end of the day, the mode is the main thing. And the mode is the most commonly occurring class. So that's easy to pick out. We're going to see quantitative not so easy. It's going to take several classes to really explain it. We're going to have to tell where the center of that plot is and give some measure of how wide it is. And those things are going to take some time to do. But this kind of shows you how the data type definitely determines how we're going to summarize the data sets. For some reason, this slide manager is really a pain today. Okay, here we go. So we're going to do categorical. And here are going to be our three steps again. We're going to look at the data. This is actually going to take some time. If you do everything by hand, you can actually look at the sheet containing the data. We're never going to do that. We're not going to really do anything by hand. Okay? Computers are such a convenience, and they're guaranteed to give you the right answer. We're not going to do anything by hand. You wouldn't want to. Then we're going to have to identify the variables and the units. Notice that's not going to be relevant with categorical variables. They have no units. So in this case, we're not going to have to worry about that. And finally, we're going to clean up the data. So we're going to talk about what that means. And this is often the hardest step. Then we're going to go ahead, we're going to plot the data, and we're going to try to describe the data for categorical by just giving a few quantities. In this case, just one. All we're going to do is we're just going to report the mode. But these three steps hold no matter what data type you have, no matter what your data set is. We do these three same steps for every single data set. Never any exceptions ever. Okay. So these are important principles to understand. That's why the whole thing's in red. For some reason I can't get this thing to work well. Okay. So first thing, we want to look at the data. Two things we're going to note. Again, the units, okay? But one of the things we really want is we want context. We want to get the background information. We saw from that example about the DUI, or the blood alcohol level. We can't draw conclusions. We can't answer questions only by looking at numbers. We need background information. Almost always, you're going to find a description of the data set. If you're reading an article in a popular magazine, it's going to tell you the background. It's going to say 2,000 people were interviewed and asked these questions, okay? And if you really want to find out the details, you can go back and actually read the article. You can track down the article itself. But we have to at least answer these three basic questions, okay? We're going to go ahead and we're going to usually delete variables that aren't relevant to our problem. So last time we saw that Titanic. We have all of those variables. We didn't even care about most of them. It's usually just to clean up the data to make things nice and simple. We take out things that we're not interested in. They just kind of muck up everything. Okay, so what we're going to do after we do this, we have to do this first. We're going to go ahead and we're going to import the data set into StatCrunch. See how to load it up. One thing you always want to know is the sample size. You want to know how many pieces of data you have for a couple of reasons. A lot of hypothesis tests we're going to talk about later on depend very much on sample size. So we're going to be interested in sample size. And again, we're going to determine if there's any bad data values, okay? So let's go ahead and look a little bit at the Titanic data set. I'm going to get out a slide link here. Let's see if I can do it. This gives you some data sets related to the Titanic. This is on the Vanderbilt University website. And if you scroll down, you'll see... let's see, where is it? Here it is. You'll see this information about the Titanic. Now it's interesting. This is Vanderbilt Biostatistics. Why do you think this Titanic data is on the Vanderbilt website? Vanderbilt's were on the Titanic. So they have kind of an interest in this, okay? So this is all the information on here. Notice there's a lot of stuff going on. I'm going to click on this part right here, this Titanic.html. And I'm not going to do it because I've already done it, but you can do it. And what you'll see is this little blurb that will come up. This is describing what's in that data set. And it's kind of interesting to read about it. So it starts off, says, Titanic and Titanic 2 data frames. And data frames is just another word for data set. The reason why they call it data frames is Vanderbilt programs in a thing called R. It's a programming language. And in an R programming language, you call data sets data frames. But it's just data sets thus. Okay, so these two data sets describe survival status of individual passengers on Titanic. It says the Titanic data frame does not contain information from the crew, but it does contain actual ages of about half of the passengers. Then it tells them where the principal source of information is. So if you want to go back and find out more information. And it says the variables on our extracted data set are passenger class, survived, name, age, embarked, home destination. It gives all these. Passenger class, now this is telling you what is this thing, P class. Refers to the passenger class, first, second, third. It's a proxy for socioeconomic class, meaning that they're using that as a substitute for the people's economic class. So if you had a first class ticket, you were considered an upper economic class, right? That may or may not be true, but it's probably pretty true. Ages and years, and some of the infants had fractional values. So that answers that question we saw last time. Why was there a person that had a year of 0.975, okay? That's the reason why. So that's not necessarily strange. There's a second data set called Titanic 2. It has no missing data and includes records for the crew, but age is dichotomized. So dichotomized means that you're taking the age and you're putting it into different age classes, okay? So here they're just binning everyone as an adult versus child. So they took a quantitative variable and now they made it into a categorical. These data values are obtained from this person, there's the email, and those are the variables. Notice it doesn't describe a lot of the variables. Okay, boat, embark, home dot destination. We can kind of guess what those are, but we don't know exactly what those are. But there's some additional information if you want to read about that. And there's tons of information about Titanic. Okay, it's really very, very well studied. Okay, so now we have a little bit of information, okay? So let's go ahead and look at these two data sets. There's a data set called Titanic and one called Titanic 2. And the question is, which one do you want to choose? It depends on what you're interested in. Okay? If I'm interested in, for example, one variable, our questions are always going to have the same form. We want to know what percentage of people were in this particular class. Okay? So you might want to know what percentage of people were in, say, first class or whatever. And they're always going to be of this form. We probably won't get to two variables, which is a shame, because those are the more interesting questions. In the beginning, we're always doing exploratory data analysis. Questions? Okay. Yeah, so this is what we want to look at. So basically here with two variables, we're interested in, is there what we call an association or a relation? In other words, does one value of one of the variables go with one of the values of the other variable more? So we might want to know, is there a relationship between survival and gender? And we may look at how to deal with that graphically. I don't know that we're going to actually get to the hypothesis test. I'm not sure we're going to get that far. But this is pretty interesting. Personally, I find this more interesting because this has all the people. It has the crew. There's some interesting stuff with the crew going on. Also due to the fact that one of the questions that's very interesting is that women and children rule. That would be interesting to kind of look at too. And here I'd be able to do that because I have both gender and I have whether the person's a child. I could get at that. So we're going to look at this first, the Titanic 2. So let's go ahead and download that. That should be in modules. So go over here. Oh, notice, by the way, I mentioned a few things real quick. So the front page is kind of cleaned up a little bit, and then here's kind of where you need to find everything. So this is the information on the second homework set. Everything you need to know. Tells the section, the topic, the due date, the late due date. The late due date you can turn in, and you get 50% on whatever problems you didn't get done by the due date. So that's not too bad. All the different problems, basically how long it takes you to do them, just to give yourself some bearings. If it's taking you 10 minutes to do a problem, but the average time was 2 minutes, you probably want to ask for help. Just give me a call. This is the syllabus, my office hours, and if you click on that, that's for the top hours for the tutoring center. So hopefully everything kind of in one place for you. Okay, let's scoot over to modules. And we're going to download Titanic 2. Oh, you know what? I didn't publish it. Thanks. I got to publish it. I didn't want to publish it before class. Thanks. Let me go back. Okay, it should be okay now. Whoops, still not. Publish. Okay, there we go. And we'll do both of these. Okay. So if you reload it now, hopefully is it showing it now? Yeah. Okay, excellent, thanks. All right, so we'll go ahead and download this. And so just note wherever you downloaded it at. Usually what I do is I just click right here. I don't wait for this to load. We're not going to use that version anyhow. And I'll open it and save it to someplace. We're going to be doing a lot of data files. In this class, we'll probably look at least 50 data files, conservatively speaking. So probably not a bad idea to just get a folder. If you want to make a folder and call it like data files, then you have everything in one place. That way, when you go to study for the midterm and the final, guess what? You can go right back to those data files and find everything real easy. So we'll just save this. I'm going to save it. Stats. I already have it saved, but data sets, and that's where I would save it. Mine's already saved there. One nice thing about Excel, it lets you get away with putting additional information. So you notice I put the key in here, okay? And I actually changed, let me make sure I change this. Let me get on and see. No, I didn't change this. Okay, that's all right. Okay, so this is the passenger class, zeros, crew, first class, second class, third class. Okay, adult, child, gender, and then survivorship. So let's go ahead and import this into StatCrunch. And we're going to do it just like before. Download it, go into StatCrunch, and click on data, and you're just going to import it. You're going to see this little tab, and you'll click data, load, from file on my computer, and you'll find it, and then you just go ahead and click load at the bottom. So we'll go through this here. Go down to StatCrunch. And I'm making a screencast of this, so if you want to go back and kind of review this. Okay. So now I'll do data, load from file on my computer. Okay, and we'll click Titanic 2. Sometimes it takes a little while to load. It may say like processing, like wait, it's processing. Sometimes it'll take a little while to load. And there we are. We're in StatCrunch. Okay. Okay, so now what do we want to do? Well, first thing we want to do is we always want to find the sample size. I want to know how many data values do I have? How big is my sample, okay? So what I'm going to do is, there's two ways of doing it. The one way is you can scroll to the bottom. I'm not a huge fan of doing that. When you get really long data sets, really big data sets, it can be tedious, and sometimes you can kind of mess up. In fact, StatCrunch, what will happen is when you go to the bottom, it'll kind of bounce a little bit. When I did this 2 out of 3 times, I got it wrong, just trying to get it from StatCrunch. So an easier way to do this, and this is going to kind of come in handy with stuff we do anyhow later on, is we're going to do this thing called summary statistics. And I'm going to ask it to tell me some information about what's in that column for a passenger class, okay? So what I'm going to do is I'm going to go to Stat, Summary Stats. So I'm going to go over here, Stat, Summary Stat, and Columns. And what it's going to do is it's going to report some basic statistics about what's in that column. And I'm going to click OK. So this is the version of it right here. So is everyone finding that? So now we just go ahead and we're going to enter what columns we want to look at. I'm going to look at them all, and there's a reason why. Notice there's like 2,800 people. It's very hard to look through all the data values and see if there's a missing value. It's easy to miss one. And so I want to look at them all. I want to see how much information was collected on all of these. So what I'm going to do is I'm going to click on the first one, class. And then if you hold down your control key and you click on the rest of them, it will bring the rest of them over too. Okay. If you have a Mac, it'll probably be different. They always have different. But essentially, I want to look at all of those. And all I want to do is I just want to look at the sample size. So all I'm going to do here is I'm just going to click on the sample size. That's it. We could do a lot of other things, okay? But all I'm going to choose is just choose a sample size here. And then I'm going to hit compute. Any questions on this? Everyone has all the variables chosen?
Real quick, how did you get to the variables in them? Is it under applets or?
Oh no! So I clicked on stats. So here we're going to be computing stats. So I say stats, and then I say summary stats by columns. Some of these things take a little while the first time you see them, but once you see them once, they kind of. You good? If you have questions, ask now, because this is what you have to do on the homework. This sort of stuff. Okay? All right, I'm going to go ahead and click compute. And notice what it's telling me. It's reporting the number of data values for each of those variables. The reason why I'd like to do it for all of them is I want to see if they're missing any of them. So you notice that all of these variables, class, age, sex, and survive, they all have 2,201 data values. And so either all the data values are present or they happen to be missing the same number of data values in weird ways, right? If they were all missing the same data value, you wouldn't even have a record, okay? So I'm going to go with the fact that they're all in. So I know now that I have 2,201 people. Okay. So any questions on getting the sample size? Now, one thing you have to know that's important is how the program you're working with treats missing data. Not all programs treat missing data the same way. So you have to know, for example, does it totally ignore missing values? Does it use them in computations? If I go to compute the mean of the age, for example, well, here, age, let's see. Actually, I don't have anything here I can compute the mean of, but if I had the other data set where the age was actually given in years, I could compute the mean. Well, what does it do? Does it count the missing data value as something being sampled, but it's giving you a value of 0? Well, StatCrunch is nice. It totally ignores missing data values. It doesn't count them, and it doesn't use them in any computations. It just pretends like there's nothing there. So if I had a missing data value, what it would do is it would pretend that there was nothing there for that variable. And that's nice. You want that. That's actually good. So we have no missing data values, and that's going to be our sample size that we're looking at. Not all programs do this. Some programs call them letters, some call them 0, which is really confusing. Yeah. I'm sorry? It would depend. Part of the reason why I chose this file was, notice in the other one, we didn't have ages for tons of people. So if I started to notice, for example, like, there's 2,201 values of this, and there's only like 1,000 something of age, I might want to question if I even want to do that. If I even want to use it to get data set. So usually it just kind of goes to sample size and how much of the data is actually present. But here we're okay. Okay, so now we got to look at the data values and see if there's any that are actually bad, all right? And so the question is, first of all, when are, for example, like missing data values an issue? Well, they're primarily an issue when they're affecting something you want to study. So this is the old Titanic data set we looked at in the last class, and we saw that there were a lot of ages that were missing. So that becomes an issue when I want to study this. I have to ask myself, do I have enough data values? I'm missing, I think, like a third of the passengers with respect to age. Okay, why would that be important? So this kind of goes to your question. If I'm studying one variable, it's not such a big deal. But what if I wanted to study women and children versus men? Okay. Notice all of those missing data values. What do I assign it to? Do I assign it to a child or an adult? There it becomes a real issue. And that's one of the reasons why I didn't use the original Titanic data set. Because those missing data values, either I had to totally throw them away, and we hate throwing away data. That's usually a terrible thing to do. Or I have to try to figure out how to assign it to a child and an adult. And that's actually hard to do. So here, age would be an issue if I wanted to analyze age. But if I'm studying things like this, if I'm just studying these variables, and the word is just, in other words, I'm not looking at passenger class and age, I'm just looking at passenger class, survive, and sex. Here, I don't have any missing data values, so this variable is not going to be considered. It's not going to be an issue. So this is one of the harder parts of statistics. This is one of the places that's a little trickier. What is a bad data value, okay? How does it affect what you're doing? Well, you can be bad in 3 different ways. You can be invalid, which means the answer is just plain wrong. If you're giving someone's height and you come across someone that's negative 5 inches, okay, either they're living in another dimension, or something's wrong. So here we either say, okay, someone wants to copy something down wrong, or there's just something really going bizarre that we don't understand. So one of two things happens. Either we go back to the original data and we check and make sure that someone didn't copy down the number wrong. And if we can't figure out what's what, we just delete that value. We may have to delete the whole record. Okay. So essentially, this is where we're trying to figure out did someone copy it wrong, and if we can't figure it out, we just end up deleting the value. This is called censoring. When we take that data out of the data set. We don't like to do that. Missing, again, there's not a lot you can do. It's just going to be blanks in the data table. If you're studying that variable by itself, and you already have enough data values, it may not be an issue. If you're studying that variable with something else, then it can become an issue, okay? And again, if I was gonna try to do that women and child, okay, versus survivor for the original data set, I had no choice. I had to delete a third of the data set, which we hate to do. It's not good to do that. Outliers, okay? These are values outside of the normal range. The common rule in statistics is that we're going to do both an analysis with and without these values. These are values that appear strange. So 7 feet is 84 inches tall, right? So if you see someone recorded as 87 inches, either they're 7 feet 3 inches or someone didn't copy down something right. So sometimes the point here is that the difference between invalid and outlier is kind of hard to tell. If you see someone that's 32 inches, they might be. There are people that are 32 inches, but it's very unlikely. So if I saw a value that was way out of the range of what I expected to see, I definitely want to try to confirm, okay, that really was an outlier and not an invalid data value. So sometimes this is called data cleaning. You hear that word. It's kind of the hot new word, data cleaning. And you're going to have to deal with this. So I'll give you data sets where for like a practice quiz and then the exams and everything, where you have data values that are invalid, they're clearly wrong, and maybe even an outlier or missing. And you have to determine what to do with them. Okay, so we want to get the categorical variables. We want to plot them. And essentially, there's only two things we do. We make the plot, and then we give some quantity that's going to summarize it, which is the mode. The thing about categoricals, there's 3 different ways we can plot it. Categorical is very easy. We can only do one thing. We can count the number in each class, and that's it. There's nothing more we can do. Quantitative is much more complicated. And so, a bar plot is just plotting the number in each class or the percentage. A pie plot is where you have a pie and the sector is kind of proportional, the area is proportional, right? Or the angular maybe is proportional to how many are in the class. And a Pareto is the same as a bar plot. But what we do is we order the bars from highest frequency to the lowest frequency. Pareto diagram is the least heard of these 3. How many people heard of a Pareto diagram before class? One? Okay. Do you know who Pareto was? Oh man. Economics, you guys should know this. I'll tell you this real quick. So Pareto lived in the late 1800s. He was an Italian economist. He was curious about everything. He had a tremendous mind. And he grew peas. And he noticed that most of his peas came from a really small percentage of plants. And he started to wonder, is that true for other things? Like, what about people? Is the most amount of work done by a small percentage? What about wealth? He was an economist. He wanted to know, is most of the wealth held by a minority? So sometimes his thing is called the Pareto principle. It's called the 80-20 principle. It says 80% of the output or results is due to 20% of the population. And it's interesting because we see that with wealth. Okay. So what's the new phrase? It's like 90% of the wealth is held by 10% of the population. People think it's because the world's unfair, but the world's naturally unfair. So that's what Pareto proved. Pareto proved that in any free market system, you always have this unequal distribution. It's not because the system is rigged or unfair. It's a natural consequence of having a capitalistic system. So it's called the Pareto principle. It's true at work. How many people find that like most of the work is done? You'll find this is definitely true in most fields. Most of the work is done by a small percentage of people. I find that true. In my field, the majority of the really important publications are done by a really, really small percentage. And you'll find that's true just about in anything. So it has a lot of applications to psychology and economics and everything. But this is one of the lesser things that he's known for. So let's go to passenger class and make all three types of plots, okay? Let's make a bar plot. We'll make a Pareto and a pie. Notice there's three different things you can plot. You can plot counts. So one thing I want you to kind of be aware of is that you're always making decisions. These are the decisions you're going to have to make when you have a data set. What do you want to plot? You want to plot counts, relative frequency, or percentages. What do you think is most informative? Counts people think is most informative, but it isn't. Because the difference between 1,500 people and 1,502, we can't really judge how important that is. Counts alone are important. And actually in the Titanic, we don't really care about counts. We're interested in the percentage. So almost always, we're really interested in percentages, okay? Relative frequency, you can go ahead and plot that, but we don't talk in terms of relative frequencies. Relative frequencies. We don't talk in terms of relative frequencies. The weatherman never says there's a 0.9% chance it's going to rain, even though that's valid. I've never heard anyone speak that way ever. He says 90%. So we tend to think in terms of percentages. So I'm going to make all of our plots in terms of percentages. Okay. So cool thing about StatCrunch, it's real easy to do. You just go to graphs, since you want a graph, and you get to pick pie chart or bar plot. I'm going to use bar plot. Notice that there's two options. What does with summary mean? One's with data, one's with summary. What does with summary mean? Yes, sir.
Is that like those column plots? Or those ones that like 0 equals row?
Close. It's actually a table where these are the values, and I put the counts in each one. I summarized them. So if I went to that and I counted, I'm not going to do it, but if I counted all of the first class, all the second class, all the third class, all the fourth class, I make a frequency table. Okay. I can go ahead and I can make a plot from that. We're almost never going to do that. You do it in the homework, but we're not going to worry about that. Okay. So in other words, that is referring to what's called a frequency chart. So this is what with summary means, because you will see this in the homework. What I'm going to do is I'm going to take all the values of the categorical variable, and then I'm going to take the frequencies, or the counts. In other words, how many times did that value occur in the table? So if I go to 0, 1, 2, 3, I'm going to go ahead and I'm going to put how many of each of those are in the table. So I'd have to count up all of the zeros. Okay, I'm not going to do that. We're not going to use summary tables. They can be useful, but we're going to go right to the plot. So I'm going to say graph, bar plot, with data. Okay. And notice that what you're going to see is this is very similar, okay, for each of these types of plots. So I'm going to select what column. So it's asking you, what do you want to plot? So I want to plot class. I'm not going to worry about any of these, but I am going to go down here and I'm going to say percent. Okay. And this is going to be important later on. So there's going to be two things. There's one going to be called values ascending, and the other is going to be called count ascending. Values ascending is talking about the values of the categorical variable. So this values ascending is talking about, in other words, it's going to plot 0 first, then it's going to plot 1, then 2, and then 3. Okay. If I do counts, what it's going to do is it's going to plot the most frequent, depending on how I choose it, the most frequent, the second most frequent, third most frequent, the fourth most frequent. That's the Pareto diagram. So So I'm going to leave that as it is. You can put in some information. Okay, so I might say this is the passenger class. All plots in this class have to be labeled. If you turn in anything, the x and the y-axis have to be labeled. I have to know what I'm looking at, okay? And this is going to be the percentage. And then you could just give something here, you know. By class. And I might put 0 is equal to crew. Okay? And so you can do it however you want, but you should explain first of all what's on the x-axis, what's on the y-axis, and what's going on. So you should have some sort of reference that here we're looking at Titanic passengers, okay? Otherwise, I have no idea what passenger class refers to. I should be able to look at the plot and totally understand what's going on without you saying anything. In business and in military, it's super important. When you go to present, the people that you're going to be talking to generally have no idea what you're talking about. They don't understand any statistics. So you really have to have plots that are really clear and easy to understand. So this is a really good habit to cultivate. And we can just go ahead and hit compute. So any questions on these properties that we want to click? Okay. And we just say compute. It does everything for you. And you might want to go back and you can tweeze this, you can change different things, okay? Notice what's really interesting though. I have this plot. What's the one thing I'm going to report? Charles.
Well, to begin with, you don't have 0.
Oh, you know what? I thought I changed it and I didn't. Thank you. Why? That's weird. Yeah, you're absolutely right. 4 is equal to crew. That's what I wanted. I thought I changed it, and then when I looked at the file, I didn't see that. Thanks. Yeah. Good. So what's the one thing I'm going to report? The one thing you have to state. What is it? Go ahead. What do you think?
Percentage.
What percentage? I got four percentages here. What is the one I'm interested in that I want to tell them what about? It's the most important percentage. Anybody? Begins with an M. Mode. I want to report the mode. So what is the mode here? Right? And so in this case, what is that? Exactly, right. So notice this is really cool. 40% of the people on the Titanic were crew members, which I would have never guessed in a million years. Basically, it's almost half of the people on there were crew members. It goes to show you probably how much upkeep there was. It was very luxurious, and that's what I would report. Okay, everybody getting this? Everybody's good? Any problems?
So is ours?
Okay.
Is ours supposed to look like this?
Yeah, mine.
You know something? I have a different data set than you have. Hold on a second. Oh, I know why. I know why. Because I never downloaded the data set that you guys had. I downloaded the one that I already had saved and I changed it in mine. So let me go back just really quick. Yeah. Hold on a second. But other questions? Is anyone having trouble with just getting things in? Yeah, let me go back and use, I'm just going to save this to the desktop really quick. Desktop. Yeah, that was why. Data load. Yeah, I wanted to use this one and I didn't get around to changing it, unfortunately. Okay. Okay, now we'll look the same. Okay. I like the other one better because I like the fact that 4 is the crew. 4 is closer to 3. Okay, that's why I changed it originally. But I didn't have time to put the change one in the thing. Okay, class. And everything's good. Okay, so yours should look like this. Okay, I didn't put the title on there. All right, good. But you can still see that 40% was the crew, which is really kind of cool. And I did frequency. I didn't do percent. So let me change it to percent really quick. The default's always frequency. There we go. Okay. Oops, you got to choose something to plot first. Okay, there we are. So we report the mode. We say the mode is the crew, and they comprise 40% of the Titanic people on the Titanic. So now we go ahead and make pie chart. Same sort of thing, pie chart from data or with data. And notice that the nice thing about StatCrunch is that the commands have the same sort of form, okay? It says, okay, what do you want to plot? I want to plot class. And I'm going to do this as percent of total. There's only 2 choices. You don't have relative frequency. It's either counts or percents. Notice that there's no X and Y label because you have a pie. So there's no X or Y, but I can put a title on here, right? Let's see if it'll let me. Yeah. So I could say Titanic passengers by ticket class, 0 equals crew. And you can mess with the color scheme and stuff like that. And so you're going to get something like that. Notice that it's harder to read, at least to my eye, it's harder to read pie charts than it is bar charts. I think in general that tends to be true. You have to go over, find the thing, find the color, find the percentage. But the same thing would be true. The mode is class 0, which is the crew, at roughly 40%. And you can mess around with that. The one thing you should never do, and I'll just say this because I see this in business a lot. So pie charts are a big thing in business. One thing you never want to do is don't make pie charts that are tilted. Does everyone know what I mean? Has anyone ever seen this pie charts where it literally looks like a pie, it's 3D? Why is that a bad idea? You're shaking your head, yes, you've seen it. Why would you not want to do that?
You're basically skewing how your eyes see data.
Skewing it how? You're right.
Because if you're pushing it backwards, then that's going to be less important than
your
interpretation of it.
It definitely messes with your perspective. The things, the sector that's close looks bigger. It looks cool, it really does, but it's a terrible way to present data. Okay, last one is Pareto. And I have these, there's the video if you want to watch it. I posted some videos from StatCrunch. They have a set of videos that are really good. But let me just stop for a second. Any questions? If anyone's really having trouble with StatCrunch. Okay. And if you don't have your computer, it's probably a good idea to work with someone else. I'd strongly suggest it, just so you see what they're doing. The more familiarity you get, the better. Feel free to work with someone else. Okay, Pareto diagram. It's almost the same. Actually, not pie plot, bar plot. Can you change that, please? Go to graph and then bar plot with data, not pie. So the last one I'm going to make is the Pareto. So you go to the bar plot with data, just like before. Everything is the same. The only thing that's different is this right here. So I'm going to use percentage again. And notice here I'm going to say counts descending. In other words, I want the things to be plotted in descending count. So the category that has the highest counts will be first, then second, then third, then fourth. Okay? And then I'll let you fill in the labels and the axes and all that sort of stuff. It's good practice for you. I've done it 1,000 times, so I don't have to practice. Okay. So everything's the same as the bar plot. The only thing different is count descending. If you don't do that, you won't get the right diagram. And we click compute again. And notice what happens is it is plotting it in descending percentage, right? The reason why I like this is the mode is always first, and that's what I'm looking for. If there's any sort of trend, I'll definitely see it, okay? If I had to do this all over again, I would have put the revised one if I had a little more time, because there actually is kind of a trend going on here. 4, 3, and notice that 1 and 2 are about the same. So you can see that as you go up in passenger class, the percentage of people the percentage of people in that class decreased, okay? Which is kind of what you would expect, right? I mean, you go to a concert, there's a few good, go to a ball game, there's a few good seats, and then most of the people are kind of wherever, all right? These are kind of the cheap seats, and this is the working class. So that's a Pareto diagram. Any questions on making any of the plots? You have to do this for the homework. You have to be able to identify it for the homework. Everybody's good? All right. So you can ask, well, which one do we use? We have 3 different ones. At the end of the day, you don't want to put 3 plots up. You're just going to confuse people. No one wants to see 3 plots. There's no one answer that you can give to this question. For every rule that you make up, I can give you a data set that will do just the opposite. So there isn't any. What you want to do is you want to try to pick out the plot. And this isn't so important for categorical, but it's very important for quantitative. You want to pick out the plot that you think really shows the interesting features in the data. But usually what I do when I plot data is I'll make all the plots. And then I'll choose which one I think best conveys what the data is trying to say. And that's one of the reasons why it's called exploratory data analysis. I mean, you're exploring what's in the data set, but you're also kind of exploring different ways to represent it. Here's a few guidelines that I use. There really are no guidelines per se, but these are mine. First of all, I think bar graphs are almost always better than pie charts. I think people can judge relative heights better than they can relative areas. There happens to be a ruler on the y-axis. It's always demarcated. You can easily go over, estimate what the values are. We're not interested in the precise values. Like the bar plot says 40.21. Who cares about the 0.21? I just want a relative estimate, okay? So I think that they do a better job of representing things. If your data is ordinal, a bar plot's the best. In other words, if the data is actually kind of ordered, usually bar plot's the best. If the data is nominal, Pareto diagram is usually best. The reason why ordinal means they can be ordered. Can these values be ordered that we're looking at? Sure, right? First class, second class, third class, and 0 is really fourth class. Okay, crew is below the passengers in third class. So this can be ordered. Why would we want to do that? We want to look for a trend. I'd want to see, as the tickets got cheaper and cheaper and cheaper, how is the percentage changing? Okay, so I'd probably use bar plot. If the data is nominal, in other words, the classes are names, like male, female, child, adult, I would probably use Pareto because I'm interested in the mode, and the mode's going to show up first. But again, which one you use is very, very subjective. If you use any of these 3, I wouldn't take off. But if you're trying to communicate something to somebody in business, then it can make a difference. You want to make one that's easiest for them to read and understand. Any questions, anything that people had trouble with? I know I keep saying that, but because this is part of the homework, and it's so much easier to ask questions now than when you get stuck on the homework, and then I'm like, okay, what browser are you using? Where did you click? That becomes a really tedious process. So if anyone has questions, now's the time for truth. Okay. So I want to go through a few little tricks that you're going to have to use. Oh, let me ask you one quick question here. Would you say there's a lot of variation in this data or not? What do I even mean by that? What is variation referring to? If there was no variation in this data set, what would this bar plot look like, do you think? It would be uniform, right? So we have a name for that. If all of these were the same, there'd be no variation, there'd be no difference. And so it's uniform, not in the sense that like, uniform you wear, but in the sense of like a uniform policy. It applies the same to everyone, okay? So this is actually showing a fair amount of variation. Notice that the lowest class is maybe about 13%. This is 40%, the highest. There's a 3 times difference in that percentage. It's not a fraction, it's 300% larger. That I would consider a lot of variation. So variation for categorical variables is when the bars have very different heights. And I would say there's definitely a lot of variation there. No variation means everyone's about the same. The counts, the percentages are about the same. Okay, so stuff you need to know when you're doing StatCrunch. The first is you're going to have to know how to put tables into StatCrunch. So let me show you this. So very often in StatCrunch, let me kind of step you through this. You're going to be given data that are just like a list. This really isn't even a table, right? Because this is all one value. If it was in a table, there had to be just one column, okay? It's just a list. And you're going to have to put it into StatCrunch. So what you're going to do is you're going to see this little icon up here, and you're going to click on that. That's going to copy it to a table. Then you can put it in the StatCrunch. It'll be a nice column, okay? So after you click here, there's a little dialog box that's going to open. And it's going to say, how do you want to open this? Basically, when you click on here, it has all the data. How do you want to open it? Do you want to open it in Excel, copy it to a clipboard, or open in StatCrunch? And we're always going to go to StatCrunch. And as soon as you do that, guess what happens? StatCrunch automatically pops up, and there's your data in a column. And you're all ready to go. So that's a nice little trick. Because what are you going to have to do next? You're going to have to compute the frequencies, okay? And you can count these by hand if you really want. But it's very tedious. And I don't know about you, but it's very easy for me to make mistakes doing that. I don't want to do that. Okay, so that's the first thing you're going to have to do. Second thing is sometimes you're going to be given a table. Okay, so this is not so easy. And let me put this in slideshow because otherwise this is going to be hard to see. A problem. There's this long description here, and then they tell you that this is where the table is. So all the data is linked to this little icon. So you're going to go ahead and you're going to click on that icon, and when you do, what's going to happen is you're going to open up this table right here. It's going to tell you for each reading level how many people were in here, and you're still not going to be able to work with that. You still can't use that. I don't know, maybe you could copy and paste it to StatCrunch, but then you wouldn't be working with the data. You'd be working with a summary table. You'd really rather not do that. It's a lot harder. It's a lot harder to work with summary data in StatCrunch than data. So what are you going to do? That's when this little icon comes to the rescue. You click on that, and then it becomes that old problem. Another little box opens up and says, where do you want to open it up? And you just say, open it in StatCrunch. Okay? So that's the easy way to do that. How many people have started working on the homework? Okay. Have you encountered these things yet? Yes?
Do you want us to put the tables in StatCrunch when we do the homework? Or can we just do everything by hand?
Oh dear, you don't want to do anything by hand. Yeah, it's way too cumbersome. You know, I mean, you can do it. You can do this stuff by hand, but it's kind of like sucking soda through a sponge, right? I mean, you can do it, but you wouldn't want to. It's just really tedious.
So, like for the homework, because I did the homework, do you want me to go back and add tables into it, like show pictures of StatCrunch using tables? Because I just used a calculator to it.
Yeah, and you'll get the same answers because all you're going to do is you're just going to enter values in StatCrunch. It's going to grade it. I mean, you can do it that way, but I mean, why would you want to do it by hand rather than StatCrunch? Because to me, isn't it a lot more work?
I mean, I'm not much of like a big technology person, so like a calculation personally.
And you know, right now it isn't an issue, but actually this is the time to learn, because later on when we're working with quantitative variables, you do not want to do them by hand. Like when you're calculating standard deviation, even though that's a very routine calculation, it just becomes incredibly tedious. So this is a good time to get, this is a gentle introduction to StatCrunch. Trust me, it'll definitely pay off. Okay. This is actually the hardest one to get to. So many people are in each class, and you want to make a plot from a frequency table. This, it turns out, is not so easy to do. So I actually have a link here. I will let you guys watch it. Let me see if I can. Didn't copy as a link. That's interesting. Huh. So this is a YouTube link. Let me see if I can do this really quick. Let's see if I got the right link. Yeah. So this is a good. So this is a good video to watch, and it will explain the details. It's a little tedious to kind of go through, but it's kind of hard to figure out. If you try, it took me about 20 minutes to figure this out on my own, and then I Googled it real quick and then found this nice little video. So hopefully that will help you with that. Let's see if there's anything else. Okay, so a couple of last things you're going to want to do. These aren't so much an issue now, but it's going to become an issue later on, is you're going to want to learn how to save data sets. So you're going to have some sort of data set that you're working on, and you're going to want to save it. So what you do is you're going to go to Data, Save, and then it's just going to ask you some details. It's going to say, how do you want to save the file? What's the file name? Do you want to overwrite any existing files? So this is kind of important, because a lot of times when we have data files, we have a master data file, and then we do stuff to it. Like in the Titanic data set, we start to delete columns and stuff like that. Well, you may not want to overwrite your original data set. I may want to save it as something else. So I may call it Titanic 2 working. Okay? So you name it. Always save it as space delimited. You can save it as comma delimited. And you go ahead and click Save. And that will save it in StatCrunch. So StatCrunch is kind of like the cloud. It will have a permanent copy of that data set. Again, this is a good thing to practice. Even though you won't need it, this is a good thing to practice. Because after you save it, what are you going to want to do? You're going to want to retrieve it, right? So this is how you retrieve it. You're going to see that there's a thing in StatCrunch called My Data. And what you're going to do is you're going to go to Data, Load, and let me show you here so it's a little easier to understand. So I'm going to go to Data, Load, and notice there's a couple of things it's asking me to specify for the location. I'm going to say My Data. And anything that I previously saved in StatCrunch is in that folder called My Data. And I click here, and I think I have a few things saved. Yeah, I have some stuff saved. So I click on whatever I want to open up, and again, it automatically opens it up in a new StatCrunch. So these are useful things. We're not going to use that right now, but it'll come in handy down the way. Let's see. Okay, so what do you need to know, right? What's testable? What's really important? So you have to know these three steps, okay? What do we do with any data set? We look at the data, we plot data, we describe the plot. That's true for every single data set. Doesn't matter from now till the final exam. Every data set, we always do this with, okay? For categorical, there's only 3 plots we can make. We only have to report the mode. Categorical is very easy. There's not a lot to it. Again, these are the things you have to look for. A lot of this goes to context. You have to know the context. What, who, and why, okay? And again, you're going to look for anything strange. Do I have missing values? Do I have values that I know for a fact are invalid? Get rid of them if you can't reconcile them. If there are outliers, if it's a height that appears weird or a value that could be possible, but it's unlikely, then we're going to do the analysis with and without. This is just kind of a rehash. And these are some concepts that you want to know, okay? The class, people call this different names. You can call it class, factor, okay? It's just the values of the categorical variable, okay? The class frequency is going to be how many people in each class, relative frequency, and percentage applied. So if you're looking at I don't want to use passenger class because the word's used twice, but if you look at gender, okay, or sex, there's two classes, male and female, all right? So sometimes we say one factor, two levels. Levels is another word for class. But we're going to stick with this. If you do more advanced statistics, you'll come across the word levels. And these are just the different sorts of ways of plotting it. That's pretty much all there is. One last thing I'll mention, and this may come in handy in the midterm, is that very often what can go wrong with plots is you have a few dominant classes, and then you have a whole lot of minor classes. So if you were to plot, for example, percentage of people by country in Europe, you'd see a few nations have a really big sector. And you'd see a whole lot of nations. It would be little slivers, and it would be impossible to read, and the graph would look really jacked, right? What would you do in a situation like that? Like England's going to be a big slice, France, Great Britain, and then you have all these maybe Eastern Bloc countries, right? What would you do with all those little countries? What would make sense to do, maybe? Bryce?
Put them as other.
Great. Combine them. Find some natural way of combining them. And this is a kind of, again, a principle we do in statistics. When we have really low counts in a lot of classes, we tend to combine them. So geographically, there might be some that are Eastern Bloc, and I don't know. You have to look at it. But you definitely want to try to group things together, okay? That's pretty much all there is for today. I don't want to go on to quantitative because it's kind of its own deal. If you have any questions, anything you want to ask me about, feel free to, but that's all we have for today. Homework, watch the due dates now. They're on the front page. No one has any excuses for missing it, okay?